Hello. So, this is my ABHA coil that I'm playing with. This is the scope. This is my TL494 driver. This is a pulse, this is a pulse, this is a pulse. These are feedback pulses from the coil. I can disconnect the coil and those go away. This is, I don't know, 64 LEDs? It's very high voltage. The probe is on times 10. This is bottomed out, and so this is 20, 30, 20, 40, 60, 80, 120 volts, up to 140, and then it decays. Now, these pulses are the same width, and then there's a gap. And the direction on this mattered a lot. Like, when I had this reversed, I could only get 12 volts out of it. But I was looking at it upside down, so it is definitely one-sided. One-sided. And this is a ferrite ring, and if I put it in and take it out, put it in, take it out, and the frequency changes, but I can just retune. Interesting. Actually, that ferrite core matters a lot. And putting it this way affects it this way. This is flat. Any other orientation. This is another small ferrite. Sideways. Vertically. So any kind of ferrite in the center of this seems to be good. This is mounted on a plastic core. This is my latest one. When I measured it, I got various resonant points. One second. So this was my first attempt. It's a ferrite core. It was better. I pulled the plastic shield out, which is holding pressure on the windings, and it slipped. This one came out really good though. But it's only one winding of paired blue and white wire, clockwise and then counterclockwise, and then they're joined so that they would be continuous. 100 volts of output, 12 volts of input. Duty cycle is actually really short. I mean, if I take off coil, no, this is the duty cycle. I should shorten that. So now it's short. I attach this, put a cord back in, and I have lights. But for 1 amp and 8 volts, I don't know. It's something. See, again, these are my pulses, and these are ringback times, and I don't know what would cause the ringback. And it's asynchronous to the pulse, and has a frequency of its own, apparently. It drops my probe. Right. So And that base frequency is 9 kilohertz. 9 kilohertz. See, there I have, in between, around the pulse, 10 kilohertz. And to the pulse, 13 kilohertz, and then there'll be 13 kilohertz after that is a back pulse. So yeah, audible frequency should be something with that. And that's an air core. Those are just barely on. I could skip a few, and they would be brighter. And we'll add, alright. And there is a capacitor attached here. Removing capacitor. Adding toroid. And then we seem to have stabilized. That's without the capacitance. But some capacitance on the outside. This is like 20 nanofarad, maybe 80, something like that. That's not the frequency. That's not the frequency. Okay, that seems to be, no, I have that turned all the way up. So we will reduce my frequency, reattach the coil, get huge feedback lines, which are higher frequency. And have a persistent frequency of their own, separate from the frequency triggering them. It kind of reminded me of when I attached this diode to ground. Right, then I get these exponential ring down decays. This is the initial pulse, and then these are the ring down decays off of this. Now it's a bouncing ground. The emitter's connected to the collector, and yeah, so we're gonna do that. and we just get a huge spike. Do we reduce power that way? Yeah, so we get more light and less power. It's only 0.64, 63, 104. A little bit. I want to isolate that coming back from the coil.